Okay, so here is a list of points. And what we're going to do is state the domain and range and then determine if it's a function. So again, remember what I told you earlier. Your domain is your x values. Okay? Your range is your y values. And so if you remember your point is an xy point, that's going to make it pretty easy. Now, a couple of rules to give you as you do domain and range, especially as you're listing them as a set of points, is one, that we always write it in order, your domain and range, from least to greatest in terms of the values of your numbers. Even if in the points given, they're not in order, we want to rearrange them. That's one of the things. The other thing is that anytime you have a set of points given like this would make a discrete graph, okay? Because I could count it and I could say I have 4 points. That's what makes it discrete. It is countable. So let's go ahead and do the domain. So again, the domain is my x values. So that would be a -1, 0, 4, and 6. And again, just double check to see if those numbers are in least to greatest order, and those are. So the next one would be my range, and it is my y values. I'm going to go ahead and just write them down. So -9, -5, 3, -2. Okay? Now, those are not in order, so I would need to go back in and change the -2 and 3 around. Okay? So I'm going to do that real quick. Now, if you can do that all in one step, that's great. Some people I know like to just mark through them and say, okay, there's a -9, -5. I look at my next two, I know the -2 would go next and the 3 would go last. Okay, so here is the next thing though, is to determine if it is a function. And again, remember, if it is a function, each of these x's can only go to one y. So I say, okay, -1 goes to a -9. Does it go to anything else? Well, no, you don't see it. 0 goes to a -5. Do you see 0 going to anything else? No, you don't. 4 goes to 3. Do you see it repeating itself? No, it doesn't. 6 to a -2. No, 6 does not repeat itself. And so if you think about it, if your x repeats, it's going to be a no. Okay? So this is a yes because my x did not repeat. Okay? So if you would like to go ahead and try number 2 and see how you could do on that, then we will check through that in class. So again, this is a table of values. This would make a discrete graph because again, I can specifically count those points. There's 4 points there. My domain is my x, okay? And I'm going to start at the bottom with the smallest, so -4, 0, 2, 7. And then I'm going to do my y's. Again, I'm going to go smallest, so that would be a -8, -1, and 3. So now I'm going to just look, does any of my x's repeat? Okay, do any x's repeat? Now I'm not going to look at the y's because I don't care about the y's. I'm only looking at the x's. And no, none of my x's repeat. So yes, this is a function. Okay? So again, you could try a number 4 and see how well you could do there. Okay, now number 5 is what's called mapping notation, if you've never seen that before. And one of the things with mapping notation, the first is always your x and your second is always your y. Now, a lot of times when I give those to you, I don't put the x and the y above it. I don't put the input and output above it, anything like that. You just need to know that the x is always your first one, your y is always your second. That means that your first one is always your domain, your second is always your range. And that never changes. So in that case, my domain would be my first ones, and again, I'm going to put those in order. And when you draw mapping, you should put them in order, okay? When you draw out your mapping notation over here. So what I'm meaning is when you put those numbers in, you should put them in order. They shouldn't be scrambled, okay? And then generally we also put the y's in order. So 0, 3, 7, 9. So then the question is this a function? Do any of your x's go to 2 different numbers? And the way with mapping you can tell it is right here, really easy. You see those 2 arrows come off of 5, so that means it is repeating because 5 is going to go to 7 and 5 is going to 9. So no, this is not a function. Okay, you might try number 6. Then back up and also tell you this would be a discrete graph, okay, because I can see there's actually 4 points there, okay. Number 7, again, this would be a discrete graph, okay, because I can, again, count those points. Now, when you go to do a graph that has a bunch of points written on it, you can do this one of 2 ways. Sometimes I find that kids make or have it easier if they will make a t-table and just record each of their points. So I'm just going to start down here at the bottom, and that point is a -3, -2. Okay, then I'm going to do this one. Just be sure you get them all in. So that's a -3, 1. I'm going to go up here. So that would be 0, 4. And then I'm going to go here. And you could do them in any order. It doesn't matter. I'm just kind of going counterclockwise there. So 2, -1. And then my last point here would be, what is that? 4, -5. Yep. Okay. And that way it makes it easier because now I have my domain is my x values. And so I have, and again, do not repeat your x's. So I have a -3, a 0, 2, and 4. Okay, so they should be in order and you do not repeat. And then my range or my y values would be, again, I'm going to put those in order. So the -5, the -2, the -1, 1, and 4. Now, is this a function? Well, again, one of the things on a graph that makes it easier is for a graph, we can do the vertical line test. And see, I could draw a vertical line right through these 2 points. Therefore, this is not a function. Okay? The other way I could look at it in this case is you see the -3 going to 2 numbers. Not a function. Okay? When you go to do number 8, I'm just going to leave you with this. We have learned on the number line how to write interval notation. So think about what all x values are graphed and what all y values are graphed in order to get your domain and range. So again, I would use on this one, just make a note here, interval notation. Okay? 2 more. So number 9, when you see the graph, one of the things here in terms of my x's, I see that it starts here, and really it's going this direction. That's where I see my graph. So when I go to do my domain, again, this is going to be your interval notation, a little different than what I was telling you about number 8. So this one is going to start at 1, 2, 3, 4, -4. So I'm going to write this 2 ways. I could say x is greater than or equal to a -4, or my interval notation. And again, I prefer the interval notation, which would be from a -4 to 8 to infinity. And again, using your bracket. Okay? Then when I go look at my y values, okay, get that off. When I look at my y values, what I'm seeing is this arrow going down and this arrow going up. So I'm really not missing any of our y values, so this would be all real numbers or negative infinity to positive infinity. Okay? Final test is it a function? That's again where our vertical line test is going to come in. Can you draw a vertical line anywhere and hit in two spots? And so, yes, if I draw right here, I'm going to hit here and here. And so this is no, it is not a function. Okay, so number 10 is going to be just a little bit different, but again, look at what all x values you're graphing and then what all y values you're graphing. Okay? Okay, so that's going to end this video. Again, go back in and try 6, 8, and well, I guess more than that, the evens 2, 4, 6, 8, and 10, and just see as a test to see if you really do understand what is going on. But we're going to be doing more of these in class, so we'll also work on them.